Hi, everyone. Thanks, everyone, for being there so promptly. We're just trying to get our speakers all lined up behind hand and making sure the audio settings are working. So thank you very much all for joining so promptly. Just going to run just for a second more to let the final participants join on. Just go 30 seconds, and then we'll kick off.
Can you see me there, Ben?
Yes, although I'm not sure who that was.
Graham Mann.
Let's open this up.
No, we can't see you at the moment, Graham.
All right. So click on there. Rename. Me. Why is that? Start a video. Oh, I'll try that one. Any better?
Yeah.
Yeah.
Yes.
There you go.
Who's that IT person giving me some advice there? Anybody? I was trying to join a meeting in Teams.
First hurdle. Right. Well, thank you everyone for joining. I'd like to welcome everybody to this second brokerage session. This is our session 3, because we had the first one, which was more finding out about some of the key priorities from the water sector, from the water companies themselves. And now this is the second of 2, where we're having quite exciting short pitching sessions to keep it quite high energy, and also giving the opportunity to have a number of quick presentations to the sector, but broadly to the water company. So I know well represented today on this call. Because we're using Zoom and because we're going to be chopping in with lots of presenters, we're going to people keep their cameras and keep muted during the event, and then through questions. If you want, I'll try and ask questions through Slido like we did last time. Some people put them on the Zoom chat. We'll try and, if they do go on there, we'll also try and pick them off. But if you pass them through Slido, if we have time, I might ask someone to unmute and come on, but purely in the basis of trying to get through as many presentations as we can as fairly as possible, then just send them through Slido. If you go on to Slido, like every other, like last time, the code or the hashtag is IWC, and we'll pick up all of your questions from there. Like I said, we've got lots of water companies on the line on this call, but we've also got Ofwat. We've got a colleague, CMAB, who is there, who I might just pass to if her audio settings are okay. Just to introduce herself and say hello from Ofwat. But if not, we'll give an opportunity between presentations, as I know she had a couple of difficulties with audio just now. Great. The only other thing to say is this session is being recorded. This session will then be hosted so that everyone from the sector can see it. It'll be up on the new website, the IWC website. Great, can we just move to the next slide? We're really lucky today. I think we've got 11 presentations, so I'm going to be as quick as I can to talk through what's just the overview of the fund, and then get going with some of the presentations. And thanks straight away to all the presenters for putting time in today. Next slide. So the same format as last time. It's really quick. It's 4 minutes for the partner presentation. Have a couple of minutes for clarification questions. If we don't get through all of those questions, the reason for using Slido is that we can keep a good record for them, and we can try and pose them afterwards, or at least not lose things. So bear with us. We can't answer all of them. We might have a small amount of time at the end, and try our best to sort of fill in any of the key ones then. But if you feel your question wasn't answered, then do shout. We'll try and get an answer back for you. And do use the voting up button if you see something on there which is similar to your question and you really want to get it asked. Next slide. So everyone now has got the distinction between the two parts of the competition. We're very much focused on the Innovation in Water Challenge at the moment, which we're pleased to say was launched last week. So we know that a lot of partnering is ongoing, has gone on. And in fact, we have heard of some presentations from last week have led to early stage proposals being put together, or entries for the competition, so which is really great. And the timeline is that the round will shut end of February 26th, and then we'll move on to the judging period, and then money awarded in April. Lots of news will be coming out about the main competition in due course, launching in spring. Next slide. Getting ahead of myself on the slides, but there you go, that's the timeline. It's quick, it's fast, and hopefully this will get things moving in the right direction for some of the innovation ideas that we've got across the sector. Last slide. Be really clear, the lead applicant for this competition is a water company, one of the 17 or one of 26 if you include the NAVs as well, and they can be led by one water company, but welcome lots of water companies working together on them, also with one partner or multiple partners. Challenging sometimes in the timeframes we've got here, but it is open on that side. So we've had a lot of questions on that in the last week. Right, so I'll go to my next slide, which I think should be our first presentation. So I'd like to get Anastasia to unmute, come on camera, and we'll give you 4 minutes to present.
Fantastic. Thank you very much, Ben. Can you hear me?
Loud and clear. Thank you very much. And then we'll give you 4 minutes. Thanks.
Wonderful. My name is Anastasia Bolton. I am from Satellite Applications Catapult, and I'm talking today about satellites-enabled solutions, or solutions enabled by space. In particular, I will be focusing on the monitoring water dam stability and modeling incident response. Next slide, please. But let me please tell you a little about Catapult, because I think it's important to understand. We're one of the 9 catapults here in the UK, non-for-profit, partially funded by the government, technology and innovation organization, which is basically looking to showcase the power of satellite and space data to other industries like yourself. Next slide, please. But why space, you may ask, and is it accessible? Because it's a conception that the space is quite expensive. You probably not know that space has been undergoing the revolution for the last 10 years, and now we have a low-cost access to space. We have absolutely free data, free imagery available from space. We have regular coverage. Of course, we have regular coverage here in the UK with this data, where we have data every 6 days over the UK, and the sensor capability increased, so we can understand and read from data from space quite more than insufficient than before. Next slide, please. So what I am proposing, we're proposing to develop remote management and monitoring system. It will be remote service to provide intelligence on the water dam stability. It will be predictive tool to reduce the risk of failure of the water dams. It will provide timely planning and forecast model in case of the emergency. It will be combined technology, it's satellite technology with already existing technology, possibly powered by ground sensors. And of course, we are offering simple interactive visualization which many could understand, and this could be scalable nationwide. And of course, we're offering collaborative approach. And Off-Watt has a challenge theme which is ideally suited for this solution. Next slide, please. In terms of the impact, the safety is of course vitally important, especially with those dams which are located upstream and nearly heavily populated areas, and the consequences of the such fail could be really great. So the proposed development of the remote management and monitoring system could really help with early warnings, which could help to save lives and prevent environmental damage. There would be the tool which would help to make fast and informed decisions. We could help to reduce failure risk and associated costs with that. We could improve asset management and monitoring. And of course, we can also have a look into the past, because satellite data goes years back, and we could analyze the historical data. And satellite technology is open to work in combination and collaboration with already existing methods. Next slide, please. You would ask how the technology works. It's very simple. I put several slides to explain. I hope you will have more time to have a look later. But basically what it is, we're analyzing the image from space, and we could understand the movement of the ground in a millimetric accuracy from space. And we could understand how points on the ground are moving. And when we have lots of points on the ground, of course, we can have a more full picture. Next slide, please. Here's an example how the technology already used in mining. This is the example how we're analyzing with the same technology tailing storage facilities, so tailing dam. Next slide. And there is some examples of how already space information helping to really create the models and scenarios for in case of the emergency, in case of the fail of the dam, where we could really have those advanced warning systems and automated systems which will predict and which will show us by minutes what is going to happen next, so we can do better planning. Next slide, please. And here I put some of the existing platforms and visualization tools. Some of it is already in place. The one you could see here for the tailing monitorings at the top, and at the bottom you could see the one which is looking over the floods and predicting the floods, and the one on the right hand side is looking over large infrastructure such bridges. Next, please. I also wanted to mention that Catapult human-centered design and collaborative approach is really important, because we're really trying to ensure that solution which we design is based on a depth understanding of the needs and requirements. Next slide, please. And here what we are looking forward, I hope to build relationship today with one of several water companies, and I hope to develop this solution into the initial pilot which we can take further. Next slide. And I know there is another space company talking after me with other solutions from space, so I put this slide together for you to read later. And the last slide, please. And here is my thank you to you for listening. And I'm looking to talk to you, happy to answer questions and happy to discuss this solution or any other particular solutions which you think could be powered by space data over the email which you see on the screen or on slide right now. I think I'm done. I tried.
Thank you, Anastasia.
That was really difficult.
You covered a huge amount then, so I appreciate that. I could see that you had a large number of slides. So if you're happy, these slides will be available at the end as well for people to digest in a bit more detail. I've been looking at questions here. I haven't seen anything coming through on Slido, unless people leave it here just for a second. People have a quick question to drop on there, then do shout.
While we're waiting, I just wanted to mention that the Catapult is quite a large organization, particularly our satellite applications Catapult, and we have various departments which are able to support us from the starting of the bid and during the development of the project as well.
Thank you. I can't see any questions there. There's a couple there, but not related to this, related to the fund. We might have time at the end. This is what happened last time. People get a bit warmed up and we have a few more questions as we go through. So I'll make sure they're directed to you at the end if you're still around at, should be about 5:15. Thank you so much for taking the time to do that and doing a presentation. So we're well lined up today for another presentation in a similar sort of area, actually, another satellite technology. And I'd like to invite Pranav up to present. I'm just going to mention again, just really quickly, this is all being recorded, so it'll be up on the website at some point with a transcript on on our IWC website. Pranav, the floor is yours. I'll give you 4 minutes.
Thank you, Ben. Thank you, Anastasia, for the excellent introduction and a segue for us. A very good afternoon to all. My name is Pranav Pasari. I'm the Technical Director and Co-founder at SatSense Solutions. Today, I'll be sharing 3 solutions that use satellite remote sensing for the management of water resources. Next slide, please. Satellite remote sensing is the use of space-borne sensors to monitor resources and activity on the ground. I'll be providing an overview of the following 3 services: catchment area management, water quality assessment, and water budget estimation. Our water quality assessment solution has been funded by the European Space Agency. These solutions meet several of the OFFAT challenge themes, specifically responding and adapting to climate change, restoring and improving the ecological status of water environments, and managing long-term operational resilience. Next slide, please. As many of the water companies here have extensive catchment management practices, the importance of having healthy catchments is well understood. I'll be showcasing how satellite data can be used to facilitate and enhance catchment management practices. Next slide, please. In this example of a catchment management case study, satellite-derived topography data is used to demarcate catchment boundaries and determine flow directions. Land use and land cover is assessed within the catchment. Hazards and risks specific to the water resources are then identified. In this case, a salvage yard very close to the reservoir with a drainage direction towards it is identified. Next slide, please. The second solution we would like to share with you is water quality assessments using satellite remote sensing. The working principles of this process are indicated here. The inherent optical properties of surface waters are evaluated, and parameters such as total suspended solids, chlorophyll A concentration, color dissolved organic matter, and transparency can then be assessed. Next slide, please. In the images here, we see TSS assessed in a reservoir and a river. As you can see, water quality parameters assessed are spatially represented for the entire water body, unlike point data collected by conventional methods. This solution can be used for the early detection of harmful algal blooms, managing sedimentation of reservoirs, and bath water quality assessments, amongst other applications. Next solution, please. Next slide, please. The third solution we'll be presenting is water budget estimation. This allows water managers to understand the amount of water entering and leaving a river basin. The working principle of this process can be seen here. The main factors assessed are precipitation, evapotranspiration, and discharge. Next slide, please. In the case study shown here, the area of the entire river basin is demarcated. The different watersheds and drainage directions can be seen. Water available within a river basin may be estimated by deducting evaporation, transpiration, and runoffs from the total precipitation. Precipitation, evapotranspiration, and changes in terrestrial water storage can be obtained from satellite data. Land data simulation models and in situ data may also be used. Next slide, please. Due to the time constraints we have provided only a brief overview of the solutions. These solutions provide numerous benefits. They are comprehensive and efficient when compared to conventional methods, and can also be used and can also be more cost effective. We would be happy to have a detailed discussion with any of the water companies. We are looking to partner with water companies to implement one or more of these solutions in an operational setting. Next slide, please. Thank you for your time and consideration. I'd be happy to take questions at this time.
Thank you for your presentation. Succinct and clear, and some things there I think which are a good call out to the sector. I've got one question here, and there might be a couple of others which come through. So sure. Let's dive into those. It's that many parts of the Western UK are covered with cloud cover for much of the time. I'd say probably most of the UK, that probably impacts. How would this impact the use of satellites to gather data?
So that's an excellent question, actually. So we actually did a feasibility study for one of the England-based water utility companies. And we actually analyzed the cloud cover, and because many of the satellites have frequent overpass over the UK, we found that we were able to get at least one water quality assessment every week. And most of these were for all 12 months of the year. So because of the frequency in overpass, satellite overpass, we were able to get consistent data over UK.
Thank you for that.
And if there's a specific water utility company, we'll be happy to do a feasibility check for them, and give them an estimate of how frequent can our assessments be performed.
Thank you. I don't have any other questions there. But I might just bring Anastasia onto the line as well, just because we've got two satellite technologies here.
Absolutely.
One, just to give a very short answer to that, but also there's a question here for you, Anastasia, around what is your protocol around data ownership and governance? And I guess that also goes to you, Pranav, as well.
Thank you. If I reply to the first question in terms of the cloud coverage, I want to say the solution I proposed is not affected by clouds, because we are proposing to use different types of the data. It's a rated data, so it's not affected by cloud data, and neither affected by night. So we always get this type of data. Probably some of the solutions are affected by other data, but not the one I proposed. In regards of the protocol around the data ownership and governance, of course, this is the question to the satellite companies which are providing data for commercially for money. I was talking about opportunity and the possibility using also free data, which is available through the Copernicus program, those satellites called Sentinel-1 and Sentinel-2, two different types of the satellite. This data is absolutely free. And also it's probably worth to remember once you download it and process the data and got the analysis of the data, you have analysis to yourself and you probably in no need of the data anymore.
Thanks for that answer. Pranav, do you have anything to add on that one very quickly?
I think Anastasia put it in wonderfully, and that's absolutely right. We do use Sentinel-2 satellite data, which is freely available, and it makes our offerings very cost effective. There might be some use for commercial satellite data, and if a customer does want to purchase that data, they could have full ownership over that as well.
Thank you. So just one really quick question here I've just seen on Zoom. We'll run out of time. So short answer to StatSense. Can you measure the ponded acreage on farmland from the precipitation event software?
Could you repeat the question, please, Ben?
Can you measure the ponded acreage on farmland from the precipitation event software that you have?
Precipitation. So I think the precipitation data that we collect is over an entire river basin. So it would be difficult to estimate over smaller areas.
Okay. Well, put that question on to Slido. Maybe you could answer that directly or drop in there as well.
Sure.
Thank you very much both for that. I'll move us on. Thank you.
Thank you, Ben.
We load up the next presentation. Great. So the Smarter Networks program is Francis or Bernard there. We'll get going on that presentation.
Good afternoon.
Afternoon.
Put my video on as well.
You ready to go?
I'm ready to go.
Bro, I'll give you 4 minutes. There you go. Thank you very much.
Good afternoon. Francis and I are from Maple. Maple helps organizations make better, faster decisions that improve your business using machine learning, artificial intelligence, and your deep subject knowledge. We would like to work with water companies for 4 linked projects, building on a very successful pilot with Welsh Water to prove a day-ahead energy forecast. These projects will reduce your energy costs, improve visibility of network performance, reduce your maintenance costs, and improve your energy forecasts. The water industry consumes a large amount of power. No, next slide, please. Sorry, we should be 2 slides ahead. And the next one, please. The water industry consumes huge amounts of power. It's the water company's highest cost after people. Most of the power is consumed in the wastewater network, where variations in energy demand are determined primarily by rainfall. Let's have a quick look at these 4 linked projects to reduce costs. By the way, on each slide, we show the technology readiness level, the TRL where we are now in orange, and where we want to be at the end of this innovation in water program in darker blues. Next slide, please. Next slide, thank you. There are 5 steps to creating your demand-side energy use forecast. You can use this accurate prediction to procure power from generators and aggregators at less cost. A better forecast means the energy companies can provide more electricity from renewables and balance loading across the grid. Using less energy and a higher proportion of green power across a better balanced grid makes a significant contribution to our net zero targets across the water power nexus. Next slide, please. We then compare the actual versus predicted energy used by each pump. If a pump is using more power than we expected, that might indicate an issue with the asset. If it's using less power than forecast, that might indicate a problem upstream in the network. These anomalies trigger alerts in your control rooms and management systems. Next slide, please. Maple can monitor the energy consumed by a pump 10,000 times a second. This very high frequency sampling helps us to characterize the pump. Changes in the equipment profile warn us of component wear and failures before it stops working. Condition monitoring of your network helps prevent pollution penalties, costly disruptive breakdowns, reduces maintenance costs, and informs your CapEx priorities. Next slide, please. Maple wants to work with your teams and partners across the sector to continuously improve forecast accuracy and interpretation of an existing and new data streams, such as those from satellites. Water companies have watched the weather for hundreds of years, but now you have access to a lot more data from many more sources in real time. We use artificial intelligence to help you interpret all that data, generate better information to reduce both your costs and your carbon footprint. Next slide, please. We work together to ensure your team's deep knowledge and long experience is embedded in the algorithms on Maple AI platform. We use models, including machine and deep learning, to understand your data and deliver informed recommendations. We connect to various devices, cloud to edge-based, deployed across diverse, robust, and secure networks. With a greater understanding of your operations, you can make quicker, better decisions. Next slide, please. To help you understand our proposals better, we've prepared a more detailed documentation, including project plans, budgets, and a risk register. These are based on our experience running a proof of concept with Welsh Water last year. We forecasted the energy required by 129 pumps over the next 24 hours with 85% accuracy. While less than 20% of their assets, these pumps use more than 70% of the energy in the network. Welsh Water are confident they could reduce their energy costs as much as 5% with this accurate, more timely forecast. Monitoring their network in real time would also reduce OPEX and CapEx. We want to work with other water companies to generate a demand-side energy use forecast and help you procure greener energy at less cost. We also want to use energy data to monitor the condition of your network. We wish we had more time, but would like to get together as soon as possible to discuss these opportunities in more detail so that Maple and you can take these ideas forward as a great innovation in water. Thank you for your time, and we welcome any questions.
Thank you for your presentation. Thanks. We're getting pretty close to that 4-minute mark, and you covered a lot of ground there, so I appreciate it. It's tough. There's a question here which has come straight up, so I'll dive into those. What are the estimated timescales to progress this technology through those subsequent TRLs? We estimate that we can move those TRLs within the 6 months of the innovation. We anticipate the Innovation in Water Challenge taking place between now and the end of 2021. So we anticipate being able to move those forward in that time period. Well, there's another question here. Is there an example related to the water-only companies, the WOCs?
No.
Not yet.
Not yet, but after today, there will be.
Pretty good. That's all the questions I can see on there. If anyone else is there, they've got an urgent one, quickly type into Zoom or onto the Slido. If not, Maple can be contacted. They have contact details there. Slide deck will be available. This is being recorded, and I urge you to reach out if any of that piqued your interest.
Thank you,
Really
Ben.
appreciate it, Bernard and Francis, for presenting today and putting that together and sticking to time there. Be in touch soon.
Thank you.
Moving on to our next presentation. We have one from Imperial College London. Professor Williams on the line.
Yes, good afternoon, everybody.
Great stuff. I'll hand over to you, and you have your 4 minutes.
Great, thank you very much. So this afternoon, I'm going to speak to you for the next 4 minutes. For the next 4 minutes, I'm going to talk to you about some multifunctional autonomous water quality sensors that we've been working on at Imperial College for the last 3 years. And I'm just showing you an image in the top right, which shows you the actual completed sensor array, which I'll describe in a moment. But it's basically the size of a small pen. Next slide, please. So the background on the project. So we've been working for the last 3 years with the Department of Electrical and Design Engineering, and also with a global automation partner. And really we're trying to deal with the following challenge. If you look at the sort of instrumentation that's commonly used in the water industry, it's remained relatively unchanged for 40 years. So devices for measuring flow, pressure, temperature, pH, conductivity, you tend to end up with very large, expensive, heavy, cable dependent, high resolutionally, invasive, permanently installed, and sensors only do a single measurement. So on the right, you can see a large flow meter. These are big, expensive pieces of infrastructure. And the question we posed ourselves is, how could we revolutionize the industry if we had sensors that were small, lightweight, cable independent, so I mean self-powered and wireless, did more than one measurement with low capital and maintenance costs, and it could be potentially put in a network pervasive way. And devices of this type would allow us to deal with some of the big challenges that Ofwat and the water industry face: asset management and monitoring for maintenance, leak detection and reduction, monitoring water quality, reducing energy consumption. And the idea really is to use the sort of sensor technology that you find very much used in mobile phones these days. And we developed some devices using the sort of sensors you see on the fingertip there, which are very small, low powered. They're easy to deploy, they're intelligent. And once we've got wireless data, there are also the opportunities around the cloud and large data analysis. And we chose the water industry as a target market for our first generation device. And the device that I'll talk about today has got 7 measurements currently. It measures water temperature, water pressure, water flow rate, water conductivity, and external to outside the pipe. It measures external vibration and external temperature. Next slide, please. This gives you a quick schematic of the device. It's quite small, and we have developed a way to essentially introduce the device into a pipe. So we have a way of inserting the device via a very small hole into a pipe, and that allows us to actually measure the properties of pressure, temperature, flow rate, and conductivity without having to pull the pipe apart, without putting large infrastructure. So we can, with a very small hole, insert our device into a pipe from 2 inches up to as large as you want. The device is battery powered, it's on Wi-Fi, networkable, and allows us to get wireless data in and out remotely from our device. Next slide, please. So what we've done is we've developed a minimally invasive installation approach involving a 6 mil hole, and we can install into pipes above or below ground. The sensor array itself is very small, about the size of a pen, 6 mils in diameter, 150 millimeters long. And we can actually replace, once we've got the installation in place, you can insert or remove a sensor array within 5 minutes. And we measure these 7 properties via the battery and wireless system. And it's a flexible platform, so other properties can be added in due course. And we measure data both on the water quality and the pipe environment. This can go to the cloud and be integrated with other water network data sets. We're currently building 10 units at the moment, and we're looking to run a field trial in 2021 to look at the performance of these sensors inside a real water distribution network. So we're looking for a water board partner and supporting funds for a field trial. And the objectives for the field trial are given there, but we're looking to see what sort of data we can obtain, how that can help you understand and better manage your water network with this low cost, easy to deploy, and battery wireless technology. Those slides are there for you to look, but I'm quite keen to have a couple of minutes to take any immediate questions that you have. So I'll stop talking now and I'll take any questions you have.
Thank you very much, Al. That helps, and yeah, I appreciate lots of information on those slides. So I'll dive into some questions here. They're coming fast through for you, and I'll start with what is the lifetime of the sensor that you know so far, anyway?
Yeah. So the first generation devices for this trial are designed for a 6-month trial, but the longevity of the devices depends on how big the batteries are you put in them. So we could have them for 2 or 3 years in long, but for the trial, the batteries are designed for a minimum of 6-month life in the field. Okay,
so that kind of answers these other questions here, is the battery life. Do you want to say anything? So is there a difference between what you're going to trial in this and what you'd hope for in the future? Or?
Yeah, I mean, that's a function of discussion with our clients. I mean, we can put bigger batteries in and we could have 2 or 3 year life quite easily if we wanted. So at the moment, it's only a question of the size of the battery. There's no other technology constraint. The batteries are quite small. The batteries are probably about 4 centimeters by about 2 centimeters by about 4 centimeters. So if we had a bigger battery, the life just scales automatically. There is also a possibility in the future of adding energy harvesting. We haven't got that at the moment, but there are scope for energy harvesting in the technology as well.
Bro, does it have any alarm functionality?
It will have alarm functionality. I mean, the devices is very intelligent programming the devices, so they'll automatically upload data to the cloud, and that can include local alarm data. So yes.
Bro, and probably the last question here, they've been quick fire. Is there a plan to include turbidity?
Well, we had a list of about 10 in our initial list, And the two that aren't in this particular device are turbidity and pH. But we do have approaches for both of those, but we really felt we needed to get a bit closer to the water boards and get better alignment with their needs. But we certainly have some approaches for doing turbidity, and that is a possible technology we could incorporate in a future version of this device.
I think we'll stop there. There's you can see here there's a line of questioning that people are really interested in terms of how that might work. It sounds like actually for this as a trial to become a partner project, there'd be some work to do with the water companies to understand exactly what they need from this to design out of it. So I urge any water companies here sort of hearing something here which they think is really interesting to be in touch with Daryl and his colleagues and to take it from there. And if you are struggling to connect in any way, then do get in touch with us. But all these slides will be available, all contact details on Daryl's or on his slides here as well. So
and I've posted my email address on Slido if you can't find it.
Perfect. Appreciate that. Thank you so much for your presentation. We just moved the slides on the touch. There we go. Great. So we're on to our next presentation is Vadim there. If you unmute yourself.
Yeah. Good afternoon, everyone. Do we need a video to launch on? Yeah.
It helps.
Okay. So I can start?
Yeah, absolutely. Floor's yours.
Thank you very much. Good evening, everyone. My name is Vadim Zagainov. I'm Chief Commercial Officer of Biomicrogel UK Limited. Our solution today is for the industrial storm and wastewater cleanup from oil, fats, and petroleum products. So please, next slide. So basically about the product, Biomicrogel is a submicron polysaccharide particles obtained from byproduct of agri-food culture. Basically, our raw material are apple, beetroot pulp, and cellulose. Our product effectively captures the oil and fats, as you can see on the picture. So we have a huge range of products and solutions for such areas as recycling of coolants, oil spill response, treatment of bottle sediments. But for this particular bullet, we suggest to use our Flocculant BMGC2. It's suitable for cleanup of bottom and produced water, industrial wastewater cleanup. And the main characteristics of the product is that it's non-toxic and eco-friendly. Basically, all our product line has 4 lowest environment hazard class. Is used lower dosages than the traditional chemicals. It's localized impurities and easily captures from the water. Next slide, please. Our main impact is that we show the treatment result less than 1 milligram per liter. The forms residue 3 times faster than the competitors. And we have, as you can see, the wide operating range of concentration, temperature, pH, and we also provide 3 main benefits. You will have the increased and constant water quality, reduction in use of traditional chemicals, and use our fully biodegradable biomicrogels. Next slide. So basically on the status, we operate in European Union, Russia, CIS, USA, Australia, Brazil. We have more than 60 patents in more than 50 countries. We have 2 production plants, 4 labs. We have our own R&D, engineering support. And next slide. Briefly about the reference we had previous year. We work in a Severstyle company. We separate more than 300 cubic meters per day of cutting fluids. And we show the result from more than 4,500 milligrams per liter to the range of around 1 milligram. That's the success. You also heard about disaster on the north of Russia last summer in Rilsk, where we bring more than 3,000 square meters of our filter close, and we bring up from the rivers more than 8,000 tons of diesel and bring it back to the cycle. After that, we get the recommendation of Ministry of Emergencies of Russian Federation. Regarding the today's bullet, we have activities in the Knauf and Russian railways with the storm water treatment, where we clean up from more than 400 square meters per hour, and we show the treatment result from more than 400 milligrams per liter to less than 0.07 milligram. Next slide. Also, we had the certificate of, after trials and tests, we received the certificate from European Commission in Horizon 2020 as the high quality project proposal, and also Equatech best technology. That's basically it. Thank you for your attention. And thank you, Ben, for your support. I'll be glad to answer your question.
Thanks, Vadim, for a quick, sharp presentation there. They're very clear about where this fits. I Can't see any questions at the moment coming up. We have one actually, dive straight in. Is the main application of this flocculant mainly targeted at oils and fats? If so, what is the subsequent separation process? Is there a flocculation process, or what do you do next?
So we can make it a recycle. So we can bring the products, oils and petroleum products, back to the cycle. Or if it's not necessary, if the constant is low, we can just utilize it. We have the 4 European grades and the scale that we can easily utilize it. So it depends on the customer needs.
Thanks for that answer. Another one here is that how do you dispose of the waste collected?
Well, we have some activators we use for this project, and also in addition, I want to say that with our current customers, we're working as the supplier of the chemicals. We also provide the service, and we also can bring the capex of for these solutions as well. So it depends on the customer needs.
Okay, but yeah, clearly whatever you've mocked up needs to go somewhere afterwards, but that'll be a question to be picked up later.
Yeah.
The final one here is that can the wastewater customer use the same chemical feed and delivery systems for existing coagulation chemicals?
Yeah, sure. It's in combination. So the customer can stay with the traditional chemicals, but he will reduce it the volume 2 or 3 times, depends on the water quality. And what's most important, that we can implement in the same scheme that the customer have now. So there is nothing special needed. We just have to look through and find out where we can input. So there's no capex investment for that needed. That's the main benefit.
Okay, thanks very much, Vadim. We'll leave it there. There might be a couple of other questions here. We'll try and get them answered on Slido.
Thank you for your time.
Moving on, our next presentation is on Waterhound. Julie King, if you take yourself off mute, turn video on. Hey, Julie, floor is yours.
Thank you. Good afternoon, everyone. My name's Julie King. I'm CEO of Waterhound Futures. Next slide, please. Waterhound has converted a proven offline predictive simulation modeling tool to cloud-based software to optimize water and wastewater treatment assets and processes. It's based on science with underlying algorithms developed and proven over 25 years. Our database covers over 300 process modules and 800 input parameters. Waterhound addresses 2 off-what challenge themes. Number 1, long-term operational resilience and infrastructure risk for both customers and the environment. And number 2, Waterhound's solution mitigates risks in sustainable and efficient ways. Our software is novel and represents a sea change for utilities and optimization of wastewater treatment because of its versatility as a tool for use in design, operations, and management, and its learning application of machine learning enables optimization against multiple criteria. For example, energy use, chemical dosing, and regulatory compliance. Next slide, please. As you saw in the previous slide, Waterhound software is a risk assessment tool, providing management with transparent, science-based data analytics from within their system that is independent of supplier bias and operator error. This includes risk assessments for performance, partial and complete component and plant failure, and environmental risks and consequent reputation risks. And importantly, using Waterhound software to optimize a treatment system goes to mitigating climate risks by reducing abstractions of local fresh water supplies, chemical usage, and by minimizing energy consumption to lower the carbon footprint of operations. This helps to reinforce goodwill within the communities where your operations are located. In terms of cost reductions, improvement in performance optimization, and reductions in water, energy, and chemicals in operations, Companies have historically reduced OpEx between 8 and 38% with hardware designed using the underlying algorithms in Waterhound software. Next slide, please. As I just mentioned, our offline model has been applied successfully in a range of industrial wastewater treatment plants for Fortune 500 companies. The software is ready to test as an independent tool or to augment functionality and versatility of existing software packages you may already be using. Our ask today is for an opportunity to apply our learning from the industrial sector to the utility sector. To do this, we require access to data and to plants, and we are able to also provide a COVID-era compliant remote access and monitoring option. Next slide, please. Thank you very much for your consideration. My colleague Jacob Tompkins will join me now for the Q&As.
Thanks, Julie. Welcome, Jacob.
Hello.
I can't see any questions coming up on Slido, so we'll just give it a moment as they come up. I guess in that few seconds you might have now is that you're just redefining that ask that you have of any potential water companies there. What sort of application do you think is closest to putting this sort of software to work on?
In the water utilities?
In the water utility.
Yeah.
Particularly to this.
Well, wastewater treatment optimization of the actual hardware and the processes as well.
And there's a question here actually just come in. So are the savings, the 8 to 38% savings, is that just OpEx?
It is just OpEx, although there can be CapEx reductions as well by using the software and design.
Thank you. Are there any real-time online case studies?
There are no case studies at this current moment as applied to utilities. For industrial, we have case studies from use of the offline model, and we have a couple from use of the software. So we have also done our own internal vetting of the conversion to the cloud-based software based on what we know has been both used and the results from using the offline model for the industrial applications. We have both, but not specifically real time for the utilities.
And so to just get this final question here, it's asking, how is your offering novel?
Jacob, I'm going to turn that over to you since you're the technical expert here.
Okay. It's able to do multivariate assessments using AI, machine learning tools built within it. It has 300 different processes for wastewater treatment plants that it can use, and it can assess about 800 input contaminants. So it's probably the most comprehensive system, and each of those algorithms for each of the processes can be built in any format you want. So effectively, you can build unique digital twins of any wastewater asset.
Thanks, Jacob. There's a couple of other questions here. They're on Slido actually, and just in the bid to stay on time here, you're welcome to answer those directly on Slido to them, or pass us an answer, and we can go through them because it's getting a bit more technical, which is great. Follow up individually between the water companies and the technology company there. Something to talk about.
Great, thank you, Ben.
Thank you.
Thanks, everyone. Next presentation. Hi, John. Thanks for being there. I'll hand straight over to you.
No problem, Dan. Good afternoon, everybody. I'm a little less tech than space and artificial intelligence, but following Storm Christoph last week, my presentation is somewhat topical by focusing on flooding and outcome delivery incentives, or ODIs. Next slide. When the water utilities came into existence, they inherited an infrastructure network, much of which was built in the Victorian era. Its creation was a result of massive government expenditure and is still considered a marvel of engineering. However, experiencing its usage now far exceeds its designed demand. ODIs, as we know, can act as a reward or a penalty. ODI penalties for internal flooding can be significant. And avoidance of ODIs, measures to prevent internal flooding, need to be taken. In certain instances, mitigation measures to the properties are preferable to the cost of replacing large sections of aging infrastructure. Our innovation aims to assist the water companies by helping to solve pressing problems that lack solutions. Next slide. Because we all know climate change is irreversible, with flooding considered one of the most widespread and destructive side effects of it. Next slide. Next slide, sorry. Yeah, so why has mitigating against climate change and achieving operational resilience, sorry, go back one, possibly, has been so difficult so far? I believe that this is due to the fact that all mass market flood protection systems are manual, meaning in order to have any efficacy at all, end users would require advanced notice of a flood, the physical strength to retrieve the items from storage and position, and the dexterity to install for them to have any use at all. Next slide. Quell is different. A game-changing level of performance, delivering 24/7 protection, autonomous deployment that doesn't require any source of power, easy to install and maintain. Quell is as close to fit and forget as we think is possible. Next slide. So hopefully our video plays. For the video, we've removed the enclosure and the lid to expose a single module of the barrier system to illustrate how it reacts in a flood event. Once the critical buoyancy level is reached, the autonomous deployment begins. The single module in this test tank has been inundated with 1.6 tons of water. The patented design controls how each section detaches from the core and subsequently attaches to the frame. This is achieved by magnetics strategically placed in each section. The entire module is wrapped in a closed cell foam rubber material. This elegant solution acts not only as a living hinge between the sections, but also as a watertight gasket, meaning that the greater the pressure on the barrier, the more it is compressed, enhancing the watertight seal. In the close-up views, you can see the black core element of the barrier. This is highly buoyant yet impact-resistant EPP, a molded foam. The Quell flood barrier system has been designed to address the negative impacts of climate change by harnessing the forces of a flood to protect properties, critical assets, and communities from that flood. We hope to collaborate with the water utilities through the Innovation in Water Challenge to demonstrate that a simple yet effective solution can address the evolving needs of customers, society, and the environment. We believe that a successful collaboration will enable us to validate our solution, which would then be readily scalable across the sector. Final slide, if possible. Apologies for the... Just go to the next slide, if possible. Yeah. So thank you all for listening. I'll be happy to answer any questions, or my email address is on screen. I'll be happy to follow up at a later point.
Thanks, John. I've managed to make the videos work while streaming live. That's always an achievement on that side. Thanks for that. I think quite a clear product there, and definitely of need. I can't see any questions jumping in, which is always a good sign also, because people get your presentation. We'll give it just a few more seconds. There's one question here. So yeah, I mean, it's quite a good question. Why the wastewater companies? What support do you need from water companies specifically?
Primarily trialing and testing in real world situations. We think that the feedback we've had from water utilities so far is that for a second internal flooding event, the ODI penalty is very severe. And obviously, water companies want to avoid those large financial penalties. So obviously, collaboration with utilities to work on that front would be great.
Makes sense. Yeah, alignment with ODIs on that side. Some quick ones here. So are there maintenance requirements?
Very little. It has been designed to be as maintenance free as possible. Again, just an annual visual inspection, checking that the one-way non-return valve is operational, and it should be fine and very minimal.
And last quick one here. What happens if the flood level, water level exceeds the maximum Quell unit capacity? It flows over.
Well, that particular unit has been designed for the new BS 85-1188 standard. So basically it's approximately 2 feet plus a wave testing format. Again, the technology, the patented technology is scalable. So in theory, it could be bigger, smaller, wider, but the physics all works the same.
Nice. Thank you very much for your presentation. Very clear. Hopefully people will be in touch on this side, and John's details are there, slides up there. This will be recorded. Thanks a lot. Next up, we've got Guy from IOSite.
Hello. Hi. Good afternoon. Thanks for hosting me. So, okay, so my name is Guy Mary. I'm the head of business development of IOSite. What IOSite does, has been doing for the last 10 years or so, is data management and analytics for water, for different types of water utilities, water systems. And I'm going to speak today about a specific solution that we offer, iShed, for water quality monitoring in surface water. Next, please. So iShed is basically a mature solution. It's an innovative, however, mature solution. It's been operational since 2017, installed at the Jordan River in Israel, the Jordan River watershed, and operated by Mekorot, the national water company. That's our first client. It's an efficient, comprehensive nerve center, 24/7 algorithm-based anomaly detection of water quality anomalies. Basically, it's about eliminating 95% of false alerts coming out from raw data, and providing propagation calculation downstream, so you can respond accordingly. If we have an intake station downstream somewhere, you can change the composition of chemicals or shut it down or whatever. It has an event management module, which provides push alerts through text messages and emails, and mobile and web dashboards, and also reporting. Please continue. Next one. So it addresses at least two innovation themes about protecting the environment from pollution, and about understanding risks and actually responding to them. Next, please. iShed is part of a broader integrated smart water suite, as we call it. It is based on the iGreen platform on the left-hand side, which is the core platform of data management and analytics. It's extracting the data, providing the business intelligence layers, reports, dashboards, alerts, and so forth. iShed is the AI type module, the algorithm-based expert module for surface water quality monitoring. We have several other modules that I will not focus on. Today, we have over 100 installations worldwide. Please continue. So we start with iShed. We start with providing some sort of like an identity card, a passport for each monitoring station. I will emphasize we are a software solution, so we connect to different types of sensors. In this case, there was the one type of sensor. So we start with analyzing historical data and providing a foundation. This is the passport for each monitoring station. Next. Then we start collecting the real-time data from the station and applying the data analytic techniques on the sensors, creating the integrated water quality index for each sensor and per each station. And only when a certain threshold has been exceeded, then an alert is being generated. So you can see green, yellow, red very intuitively. Next, please. And upon an event, there is a downstream propagation calculation, a second algorithm, which is being triggered, as I mentioned, helping you respond to that specific event. Next. You can see examples of the dashboards, the web dashboard, as well as the mobile dashboard. These are actual screenshots from a real installation, the one that I showed. Next, please. and also actionable smart reports. So twice a day, or as you define it, you can get smart reports, providing you insight into what's happening in your water, in your watershed, in your surface water source, and also alerting on anomalies in sensor behavior. Next, please. And as I mentioned, an event management module based on rules engine through text and email. Next. We have another project in Chicago, the H2Now Chicago, real-time water quality monitoring in the Chicago River. The thing about that is we collect different types of data from different types of sensors. Actually, a UK-based company is called RS Hydro Proteus. And that's the second project we have with iShed. And next, please. And to summarize, I can stop here. I think it's basically it's a proven solution. It's flexible to address different types of surface water sensors, and yeah, that's it.
Thanks, Guy. Thanks for stopping at that point. Just going to check Slido. Yeah, it's probably a good question to start on. It's like, what makes this solution innovative?
So I think, as far as we know, that's the most innovative and accurate and proven solution for real-time water quality monitoring in rivers and watershed and surface water. So it's not just about the data, the raw data. It's about applying the algorithm. It's about elimination of false alerts, turning it into an actionable solution. So you get the layers of getting the various types of data, integrating them from the sensors, and then providing the analytics as well as the alerts and the event management. So it's kind of like a comprehensive solution. And I mentioned the downstream propagation. So as far as we know, it's the most advanced and proven solution. As I mentioned, it's been used by Mekorot to protect Israel's northern watershed for 3 years. So it's proven. It's another aspect.
Cool. There aren't any other questions, but I guess we've got 20 to 30 seconds. What is it you need from a water company in terms of a potential partnership project here?
So I believe water companies that have source water coming from surface water, I think will probably ask to connect to their monitoring stations if they already have sensors installed to collect data from those sensors, and maybe also other types of data like laboratory data and weather data, and kind of like do a pilot like we're doing in Chicago right now. And hopefully we can help them identify in real-time water quality anomalies. Yeah. So.
Thanks, Guy. I think everyone should have a look at that case study, see if there's something interesting. Guys, details on here, be up online soon. Thanks very much.
Thank you.
On to our next presentation. Do we have Dr. Abbas there?
Yeah.
From John Moores. Good to have you.
Oh, thank you very much, Ben.
I'll give you 4 minutes now. Thank you very much.
Thank you. So my project is an innovative design for separate sewer system. Next slide, please. So the problem tackled by this design is that combined sewer system makes up about 60 to 70% from the sewer system here in the UK and many EU countries. And this has caused a serious pollution problem because the combined sewer overflow. So when the flow exceeded of the capacity of the combined system exceeded the flow discharged directly to the river. And the challenge that water company has is that to do a separate sewer system actually is lack of space, especially here in the UK or in Europe, whereas narrow streets is more common and already occupied by a complex network of infrastructure. And finding a space to place a traditional separate sewer system is very challenging. So next slide, please. So the motivation behind this research that all new regulation imposed of using separate sewer system in all new development and combined system is limited to use for replace or extend an existing system. So separate sewer system has 2 manholes, and the water companies now set up the separate sewer system in all new development upstream the network, but downstream it connected with the existing combined sewer system. And we have a chance to chat with DEFRA about this, and the answer that we need to be ready for the future to complete separate sewer system. Next slide, please. And this research is one maybe attempted to try to separate or provide an innovative separate sewer system, can reduce the space and save construction cost and time. So we, through this design, we gathering the two systems into one new system, can maybe reduce the space and construction cost. So instead of two manhole using by traditional separate sewer system, we use a new one manhole that can maybe the flow come and the pipe at the top, enter the water, enter the external chamber, flow around the inner chamber and exit from the next top pipe. Foul flow can flow on the pipe at the bottom and connected with the bottom inner chamber and exit directly from the next pipe. Next slide, please. So this solution represents a cost-effective and space-efficient alternative to the conventional sewage technology that has used since 100 years ago. It's a protect public health environment by using separate sewer system, reduce initial cost by 10%, decrease the construction time by 40%, and decrease the footprint by 20%, and this will minimize the disruption in city street through an installation process. Also, this system has been tested and it's improved the structural and hydraulic properties which can mitigate from the flood risk. Next slide, please. So we test this new design in Liverpool John Morris University through more than 4 years using a physical lab for structural and hydraulic performance, used the result to validate FE and CFD model, and we believe that we are ready now to move for the next step, which is scale up this design for test in the site. And we look for one water company to provide us with the site for testing, and maybe we use it like as a platform to go for OFAT competition. Next slide, please.
Just to wrap up, please. Yeah.
Yeah, with that, I would like to thank you. I'm ready to have any question, to receive any question, please.
Thanks. We've got a couple of questions here, and maybe it's just a clarification on the solution. One here is, what's the green box labeled TP signify?
Can you,
as well.
Can you repeat the question, please?
Yeah, what does the green box labeled TP signify?
Signify? No, I'm not get the question actually.
So there's on one of your slides for the innovative design for a separate sewer system. Go back one here on the left-hand side there. TP. I think that's
the treatment plant. So combined sewer system. It's moved. The foul. It's moved to treatment plant before discharge to the rivers or water courses actually. So this is a treatment plant. Yeah. So for that.
And is this for new installations, or it can be retrofitted?
It can use for both actually, to separate an existing system, and I have maybe special video and explanation how we can separate an existing system, or can maybe set up a new separate sewer system.
Okay, and I think that answers the other question there, is around is this solution around the manhole or actually relaying of separate storm and sewage work networks?
Yeah, it is a present a new design for manhole, different from what we used it before for more than 100 years ago. So it is a new design for manhole, allow to using the separate sewer system efficiently.
Thank you. And just one quick one as well. how does it accommodate different pipe gradients and pipe diameters?
And one trench. So we test this also in lab. We set up different pipe diameter, and it's work. There are special criteria to do the installation, actually.
Thank you very much, Dr. Abbas, for being with us today. Contact details are there. Thank you
very much.
I'm going to go across to 8 Power now. Paul Egan, if you're there. Oh, there you are, Paul.
Oh, hi Ben. Thank you very much.
There you go. It was yours.
Great, thanks. So good afternoon, everybody. Ben and team, thanks very much for the opportunity for us to introduce 8 Power. My name is Paul Egan and I'm CEO. 8 Power are a Cambridge-based technology company focusing on UK water to use smart sensors, software and analytics to make your dark, unmonitored assets into smart, intelligent machines. And we're doing this with a system we're calling fit and forget condition monitoring. So next slide, please. So I just want to take a couple of minutes just to kind of set out the vision here. So imagine if the right people in your organization were able to get the right information at the right time, how that could improve your decision making. We'd also like to see if you could see all of your assets and lower your risks, what would that do to help you deploy your limited resources? Now, a big one is imagine if you could move from reactive maintenance to scheduled maintenance and asset failure could be prevented. So that not only would that save you OPEX and CAPEX, but it would also meet or exceed your ODIs. And this may sound like science fiction, but these are things we're actually doing with our customers at the moment. So next slide, please. So 8 Power, we're solving challenge 3 around resilience and infrastructure risk. So without regular inspection, we know that a lot of assets can carry risk of failure, some assets more than others, and unexpected failure can lead to all kinds of problems that you see listed there and more. And I'm sure that some of the audience know some of those problems only too well. So the best way to mitigate some of these risks, we think, is to use sensors and software to automatically track and report asset health and alert you of developing issues. And we use things like vibration and temperature to actually check asset health. And if we can fix those small problems before they develop into critical failure, we think that's going to be the key. Now, to give you a little bit of context here, in 2018, UKWIR published a report showing that less than 5% of UK water assets have any kind of condition monitoring. Well, 8 Power is now hoping to address that need by making an easy to retrofit system to provide assets with data and insight in a readable way that will enable you to do early intervention to prevent major asset failure. Next slide, please. So I just want to take a couple of seconds just to look at some of the data. And again, we've focused quite hard on making sure we get the right data to the right people. And we're grateful for Anglian Water to be able to share one of these historic screenshots. So in the first slide, you can see there that we've really got something that's designed for managers. It's to have a quick over glance and see exactly what's going on there. But obviously, if you need to, you can click through and see more detail. So the next view would be more for someone in operations or in control room that might want more detail, say actually specific temperatures or maybe vibrations or other calculated KPIs. Now for problem diagnosis or by a tech or a service partner, you might want to be able to see more data. And in this view, you can see how we've got trends of data going over time. And it could help you maybe plot some of the other things that we're seeing there. And obviously for the expert, we've got full fast Fourier transfer or FFTs or a spectrum view of individual vibration recordings. And the trained eye, you can see the various things going on there. So these views are available on desktop and mobile. And obviously we've got an API to your existing platform. And obviously alerts can be by text, email, tweet, or almost any other kind of platform. I think flexibility is our key when it comes here. And I've got another slide on data sharing shortly. So next slide, please. So we're up and running on 15 sites with 300 sensors in the field. We've been collecting hourly data. Our system's in production with Anglian, Yorkshire and ABB, and we've done quite a lot of work with Severn Trent as well. We'll shortly be launching a new sensor that gives 5 years worth of data on a single battery. And obviously with the opportunity for energy harvesting, we can actually make sensors maintenance free for 10 years. And we've got some new software things coming out as well. So next slide, please. In terms of an ideal partner, we'd be looking for a partner that wants to run a project rather than a pilot or a trial, and they want to move to condition-based maintenance. So, and we think to get the best value out of this, it's going to be given the opportunity to both share in data internally and potentially with external customers as well. So we think that data sharing and particularly automating response around conditioning is going to be the next big thing. So next slide, please. So here's the summary really of our fit and forget technology. It's field proven and it's being used with recognized UK water companies at the moment. So we want to help you reduce your OPEX and minimize reactive maintenance. Many companies are starting on their digital transformation journey, and we'd like to share the start of that journey with you and your partners by making it possible to actually see those assets. Final slide. So my contact details are on the screen and it's in the slide and they'll be distributed, and you can find me on LinkedIn or Twitter. We'd love to chat. Thanks for listening and happy to take any questions.
Thanks, Paul. Thanks for going through that. Again, lots of information there and pretty clear about the ask to the sector. I can't see any questions jumping through at the moment. One's there, so we'll just give it just a moment.
Yeah, sure.
There's one here. Do you need a sensor for each piece of equipment?
So what we've done so far is we prefer, actually, depending on the asset size and class, so certainly on larger assets, we would tend to put a sensor on the motor-driven bearing, the motor non-driven bearing, plus either 1 or 2 pump bearings if we've got access to those.
Nice and clear. In the interest of time, there might be some questions on there. Feel free to dive in and answer those yourself, or we'll try and round up for people as well. Thanks, Paul. I think, yeah, again, it's very clear there what you're sort of asking to the sector. So thanks for being on here with us.
Great. Thanks, Ben. Thanks, everybody.
So we're down to the last presentation today. Good to know it's not got to the very end and everyone's dived off. We've got 78 people still online. I think we had 81 at the top. So really great that everyone's still here to hear from field. And I'll hand over the floor to, I'm not sure who's presenting from field actually.
It's me, Ross.
Hey, Ross. Thanks for coming along.
No problem.
I'll hand over to you. Floor is yours for 4 minutes.
Brilliant. Thanks, Ben. Thanks for having me, and thank you to all the other speakers today. My name is Ross Sammer. I head up the commercial side here at Field. So Field was born out of collaboration between Boston Consulting Group, OTPP, Koru, and SGM. So SGM were looking for ways of improving worker safety, streamlining processes, and removing some of the key frictions utility companies face on a day-to-day basis. So this is why we were developed. Initially, the solution was focused on improving safety and productivity, but the knock-on effect we found is that by streamlining these processes, there's reduced strain from regulatory pressure and public expectation. Next slide, please, Ben. So in terms of the key frictions that were identified during the discovery phase, they were focused around 2 key areas, which was field workers and managers. On the field worker side, we found there's a considerable amount of time was being spent on paperwork, which slowly was becoming more of a tick box exercise than anything. Then oftentimes workaround solutions like text messaging or WhatsApp were also being used, meaning data is being stored in lots of different places. And when problems do arrive, it can be a nightmare trying to locate all the necessary information. We then found repeatedly that job logging and risk assessments were being completed at the end of the job when people are rushed or have forgotten key elements. And this was frequently happening on smaller jobs where experienced field workers felt a risk assessment wasn't deemed as necessary or as important. So moving on to the manager side, we found that there was limited capacity for managers to visit every site, resulting in it becoming increasingly difficult to keep workers safe from a distance. Managers also didn't have all the data to be able to make informed decisions or identify what issues are common, making it hard to anticipate problems that may come up on site. And without this data, it's difficult to organize their day or prioritize their workloads, as historically all of this information was stored on paper and never captured in systems. Next slide, please, Ben. So that's where we came in. As a top level overview of the platform, Field enables effortless data capture through visual risk assessments and allows real-time visibility of site activities. The AI-based platform pulls unstructured data from recorded videos and creates a risk assessment alongside recommended controls associated with these risks. So what started out as predominantly safety-focused tool has developed and had wider benefits around productivity and streamlining operational processes. And that's the key as to why we're different. Some alternative solutions recreate paper forms, resulting in the same inefficiencies and issues, but with Field, workers are safety conscious before starting a job, and managers can monitor this, allowing remote collaborations amongst teams. This data is then fed back into the Field platform, surfacing actionable insights, allowing managers to focus on improving operations while still minimizing risk. So these are the initial improvements, but the secondary benefits that are gained from this allow companies to transform their core operations, enable remote collaboration, and especially in times of COVID, reduce the need for face-to-face contact, whilst also exploring ways of optimizing processes deeper and ultimately providing a better service for the end customer. Next slide, please. So in terms of the work we've been doing with SGM, we've seen some impressive benefits over the initial 7 months together from both safety and a productivity point of view. So we're now embedded in all 14 of SGM's depots across the country and been used in nearly 14,000 jobs since rollout. These benefits include a 36% improvement in safe days, 89% of jobs being completed faster and safer, and over 6,000 pieces of paper being removed from the process. The indirect impacts of this has enabled SGN to continuously improve their ways of working, whilst also increasing the span of control between managers and field workers. Next slide, please. So this quote from SGN CEO highlights that implementing field has benefited the entire company and its customers, not just the field teams. And the ultimate benefit to the end customer is a safer, constant supply, resulting in increased satisfaction and reduced costs. Next slide, please. So why are we presenting here today? We've already developed with SGM within the gas industry and now making our first moves into water. Initial feedback's been positive, but we're looking for partners within this industry to help tailor the field technology to deliver these same benefits. We would start with an initial scoping whereby we work together to identify any water-specific changes that need to be made, then beginning an initial pilot where we work closely to drive adoption and gather intelligence, and finally optimizing the process to deliver tangible improvements to you and your companies. Next slide, please, Ben. So that's me. Any questions from anyone now? But thank you for having me. I hope it was interesting.
Thanks, Ross. Wrapped us up well there, kept us on time. Thanks for a great presentation to round out today as well. I'm glad everyone has been able to stay with us till the very end of 5:30.